In today's episode, Jessica asks, how would you differentiate hypothesis formation and searching for relevant variables without data snooping? Good question. So data snooping is more commonly known as like curve fitting or data dredging. And it's what you do when you take a data set, you run an analysis of it, and you formulate a hypothesis, which is normally in the reverse order you do things. And your hypothesis perfectly fits the data and the results. It's also something in the academic world is known as harking, hypothesis after results are known. And it's obviously very dangerous because if you draw a conclusion on a data set without any preventative measures from this particular type of bias, data dredging bias, you risk coming up with flawed conclusions. So, real simple example. Imagine you have, let's say, a data set of highly ranked pages in SEO, right? And the number of Twitter shares they have. And in this data set, you run an analysis. You find out there's a strong correlation in this data set between Twitter shares and SEO value. And so you come to the conclusion that sharing on Twitter increases SEO value. And you're like, awesome, great. You're excited. You've made a new finding. You publish a blog post about it. Maybe you put a white paper out about it. And then people take your advice and they're like, this isn't working. I'm getting the Twitter shares just like I saw in your paper, and I'm not seeing any change in SEO value. What happened? Well, what happened is that you had a bias in that data set, or there was something in that data set that led you to an erroneous conclusion, and you had no way of testing your hypothesis because you used the data set to draw from it. The way to avoid this is a process that you should be very familiar with if you've done any kind of like A/B testing in marketing. In an A/B test, you have your web page, you have the control, which is the web page as it is, and you have the test set where you've changed colors or buttons or text or whatever, and you're comparing the two. The same thing is true in this data. If you had that data set of Twitter and SEO data, you would take that data set, randomize it, and then cut it in half. Half of it you put aside. The other half, that's the half you would do your analysis on, because there is value and it is legitimate to look for patterns in data before you draw a hypothesis. Sometimes you don't know what you don't know. So you've got to look at the data and see, like, is there a there when you're looking in this data set? Is this data set, is there anything of interest in it? But by cutting it in half, you've set aside half of it and you build your hypothesis, and then you have something. You run your analysis, you draw a conclusion. Hey, look, Twitter shares and SEO are highly correlated. Awesome. And then you go to your holdout, your control data set, and you run the same thing, go, and you realize it's not there, right? That same conclusion that you drew from your one set is not in the other, and you know that something has gone wrong. You know that you were curve fitting, essentially. Most good machine learning tools, like, for example, IBM Watson Studio's Auto AI, not only do this automatically for you, they actually they'll split into 3 sets. There's a training set, a test set, and a validation set. And so it cuts your data set into 3, and it draws a conclusion and what algorithm it's going to use on the training set. And then it validates with the test set, and then it validates it again with the validation set to really make sure that you've got a legitimate conclusion. We, as marketing data scientists, have to take that same idea and implement it in practice with our data. If we don't even do the validation set, then we're going to come up with these weird conclusions that are going to be incorrect. So that's what data snooping is. The challenge is twofold. Sometimes we don't have enough data. And if you snip that set in half, you may find that you just don't have enough data to even draw a statistically valid conclusion, which is always a real problem. And also, sometimes you may find that even your data set sample itself has issues, right, compared to the wide world of, say, SEO. There are, trillions of web pages out there. Even if you're looking just in your niche, there may be specific oddities in your data set that you might not have enough, you might have biases in it. So one of the things you have to be careful of is making sure that you're bringing in enough data that is randomized, that is blended, that is big enough that you're not going to draw incorrect conclusions. And again, you have to counterbalance that with, is there something that is truly unique about your industry that wouldn't be true in other industries that might affect, in this example, SEO? So there's a lot of gotchas here. This is an interesting challenge because from an overall, a big picture perspective, this is not a technology challenge. This is not even a mathematics challenge. This is a process challenge, to know that you have to do that. And a lot of the time, especially with data science and machine learning, if the tools don't do it for you automatically, people don't know to do this. It's a process problem. And knowing that you're supposed to do this, you're supposed to do cross-validation, is really important. This is also a statistical problem. And even though statistics and probability are building blocks for data science and machine learning, a lot of folks who rush into data science don't get enough statistical training to know that there are these time bombs or landmines or whatever you want to call them in the process so that they can avoid them. If you're doing exploratory data analysis, again, know that you have to hold some of it out, or you're going to have to go and get more of that data from the same source and under the same conditions. And again, make sure that it's randomized. You want to mix it up as much as you can so that you have a representative sample when you're doing your hypothesis creation. It's challenging. It's challenging. It's challenging to know to do that. It's challenging, especially when you're looking for a result and it's not there. Even after you've done some data snooping on half your data set and there's nothing there. Knowing that there's going to be a bias in your own head to say, like, I want to find something in this data is important so that you can prepare against it. So really good question. It's a challenging question. It's a question that, again, inexperienced folks are not going to know to look for. So make sure that you brush up on your Stats 101, take a course in it, or if you're in my case, take a course again, so that you are aware of what can go wrong when you're doing this type of analysis. If you have follow-up questions, leave them in the comments box below. Subscribe to the YouTube channel and the newsletter. I'll talk to you soon. Take care. Want help solving your company's data, analytics, and digital marketing problems? Visit trustinsights.ai today and let us know how we can help you.